All right, this is part 2 of the Angry Kai clone game. Just get my lesson plan up here. Okay, so we left off at making our launcher, and the key is that whatever you use for your launcher, that you have a scene component that's going to act as your spawn point. Okay. Who is following along, just so I make sure that I know you're following along, Johnny? And okay, all right. Let me make sure that at least you two guys are not left behind. So Johnny and Brianna, you guys both have the spawn point. You have a launcher. Mm-hmm. Okay. Cool. So what we're going to do is we're just going to make it so this is a launcher. When you click, that it spawns the ball that we made. That's it to start. And then we'll figure out how to make it actually work correctly with power and aiming in just a bit. So the first thing we're going to want to do is make sure that this launcher can respond to inputs. So if you go to the defaults of your launcher and scroll down to the input category, change the auto receive input from disabled to player 0. Because we're going to bind this to the left mouse button.
Would you have to set this up for every player if you have multiple players?
You can do this differently. Instead of doing this enable just for one, you'd probably do on event begin play here. You'd say, hey, enable input.
No, applies to every player.
Yeah, you'd say like, hey, enable input. You do that, and you'd go through every player controller this way, but we only have one player, so it's easier just to do this. Okay, so in your blueprint graph, and you guys stop me if I'm doing anything or you just need me to hold up for a second. Let's just bind the left mouse button to spawn the spheres. So if you go to your blueprint and add the left mouse button event and hook that up to, we're going to just call spawn actor from class. So add one of those guys. So spawn actor. And in this drop-down box for class, just find your blueprint that you made. Mine is BP_Kai. So there's a drop-down box next to the class. Okay. So once you've spawned that thing, Kai, are you following along too? Mm-hmm. Okay. Do you have this then? I do. Okay. You don't have the error? No. That's fine. I only have the error because I clicked compile prematurely. It's fine. Grab your spawn point from the left. You should see it show up in the left under the variables list, and drag him into the level. I hold down control when I drag to do a get. And pull up. What's that? It's here. If you go to your components, you should have one of these. If you don't have one of these, Kai, add a scene, just a scene, and name it spawn point. Okay.
And that's separate from the root, right?
It is. We're going to make more stuff as a child of the spawn point. There's going to be an arrow that kind of points in the direction that's going to be launching, and the arrow is going to scale up and down based on the power that you're shooting at. Okay. Are you good, Kai? Did you add a spawn point? You got it? Okay. So now when you added it, it should show up on the left here. So drag him into the level, grab a reference to him, and pull a wire off of him and type get transform. And what you want to do is use, you can actually do get world transform. You want the world transform of the spawn point. This will mean that the spawn point will be used not only for the position, but also the rotation of the spawn point. Okay. You can just plug that directly into here. So you should play, and what should happen is that, oh, we didn't actually place one of these things in the level. That would help too. go into the map, and I'm going to put my launcher here. Oh, it's so tiny. I'm going to scale this guy up a little bit. I'm going to rotate him to be in the correct direction. I'm actually going to line him up with my cubes. So these cubes all have a X orientation of 2440. So I'm also going to put this guy at 2440. Okay. And I'm going to just, I think I'll scale this guy up. Actually, I'm going to scale him up in his blueprint. So he's a little small on my screen. He may not be that small on yours, but I'm going to scale up his meshes. I think I'm just going to scale each of the meshes up like 6 times. There's a reason I'm not scaling the root, because I don't want to scale the balls that are coming out of the spawn point either. Because we're using the transform of the spawn point, that means that anything we spawn from there will also take the scale of this guy. Right now he's nice and he's at a scale of 1, which is what I want. If you scale your meshes up in the level, your ball that you spawn will probably be scaled up too.
Could you shoot it back for a second?
Oh, here?
How does that work though? Because those are separate blueprints. Why would this scale be relative to the slingshot if they're separate blueprints?
They're not actually separate blueprints.
Oh, not? You're spawning it inside the...
It's spawning here.
But I mean the actual ball itself, is that a separate...
Because the ball, it's asking for the transform of what you want the ball to be, and we're giving it the spawn point transform. The spawn point transform is based on the transform of the root scale. So if I scale this guy up, it'll scale this guy up as a child, which will then scale the balls.
That's cool.
Yeah. Okay. Here's my spawn point. Okay. So I placed one of these guys in a level. He's scaled up now appropriately. He's kind of big. It's fine. And when I click, out come the balls. Right now they're kind of, they're not going anywhere that I need them to go. I don't really know what's up with the resolution on this thing. It's like super blurry right now. It's depth of field. Hang on for a second while I adjust the depth of field. Are you using the, where is your spawn point? Is it inside, when you click on your spawn point, is it actually above the geometry of your slingshot thing?
Let me check again, but I moved it up when
And do you have it hooked up to the left mouse button here?
it is above the...
Okay.
And
It does.
it's the left mouse button press.
And did you have your class selected here in the drop-down box?
Yes.
And you're pulling the transform off the spawn point, right?
Yeah.
Okay. Oh, did you, you probably did set this. Go to the defaults where it says auto receive input. Make sure that's player 0.
That is not this one, so that's probably exactly it. For the root scene or for the spawn point?
Oh, that thing? That thing is just on the input. This is in the defaults.
So it was
Under input.
player 0.
Should get something that just spawns these things.
Whoa. It spawned a ball in my face.
That's fine. It's fine if it's a little weird. It's okay.
It looks straightforward.
Yeah, we didn't control how these things move. There's a lot of little bits to making this thing work. We're actually making what is actually a 2D physics game in a 3D world. So we're gonna have to do a little bit of constraining in just a bit to make sure that balls don't fly out towards you. So here's something. Let's just start off with this. So when you're playing your game, if you jump into it, notice that my balls kind of like fly everywhere. Like they're actually coming, some of them will actually fall outside the world, and they're actually kind of stacking. I kind of want them to be stuck, though, on a plane that is only on one axis, right? Like I don't want this ball here that's chi rolling at my face like that. So yeah, what you can do is we can constrain the axis that those balls simulate physics on. So go back to your ball blueprint now. And I want everyone to do this because otherwise your balls are going to go everywhere, and I don't know if that actually makes sense. Go to your ball blueprint and scroll down to where it says physics. And we are going to lock an axis. And this basically lets us constrain so that that axis is effectively ignored when it's simulating physics. It acts as if that axis doesn't exist at all. So you're going to want to lock the x-axis, most likely. That's what it is for me. I don't want it to move in x. I only want it to move in y and z. So up and to the right or left.
No, I thought X was right and left. And Z
Well,
was, like, back and forward.
not in this map. It's not. Like in this map, x is this way, like into and out of the scene. So go to your ball blueprint. Go down to physics and lock. For me, it's the x-axis. If you're seeing the balls in your level go in a weird direction, they're probably a different axis. We're also going to do this for the wall. The wall is also going to have a locked axis so that it doesn't fall into and out of the scene. Right, did you find it, Brianna?
Yes, I did.
Okay. So at the same time, we're going to do this for the wall too, Brianna. So go to your wall blueprint and go to your mesh and also lock its axis to be on x. It's effectively removing the x component, so it can't move.
Multiple axes?
Yeah, if you do custom, you can do custom locked axis.
I assume 1 is true, 0 is false.
Yes. 1 is locked, 0 is not locked. Okay, so now that I have that, if I go back and play, if I compile and save everything, and I play, now the balls that I shoot out of this thing will only ever be stuck on the same plane. So they actually they cannot roll towards me. So see how they're like stacking up like that?
Mine are all spawning and then not moving.
Are they? Yeah, they're not going to move yet. We didn't apply any force, but they should like be able to stack up
No,
like
I
that.
mean like on top of the slingshot.
Are they just piling up on top of one another?
There's only one, but I can see in the scene outlier that it's adding more. But they're all on top of each other, inside of each
Do you have
other.
your collision turned off on the collider? Because they're probably stacking on top of each other.
Might be it. Let me check.
So they look like ping pong balls, but they're actually chi. It's actually chi.
Oh. When did that get unclicked? Simulate physics would be very important.
That would be very important.
Make sure you have the event on tick too.
Yeah.
And these should these be generating hit events as well?
Yes, both the wall and the ball should be generating hit events because we're about to just add that behavior after we add the ability to launch them in a direction. I want to fix my post process here.
One of them is staying perfectly still. The rest that's
Are they rolling at least?
The ones that fall down are,
Okay, that's fine. That's totally fine.
but there's still one that's like hovering.
That's totally fine. It's fine because they'll kind of like rest on there for a little bit.
No.
It doesn't really matter because we're going to give force to them anyway. So, all right. Let's now do the next thing. Johnny, you good? Did you have guys spawning? And are they constrained to the YZ? Okay. All right. Let's do the actual launching. So this is where we actually get to the gameplay. We have all of the separate pieces that we need. We've made them one bit at a time, but now let's hook them all together. We're actually going to do some blueprint work now. So go to your launcher. We're going to start with this guy. As it stands now, the launcher is basically making a ball and then not doing anything with it. What we want to do is we want to be able to shoot the ball towards the wall. How about the first thing we do, let's just make sure we can apply any kind of force to the ball that spawned. I just want to give these guys some velocity so that they go and they move forward, all right? So what we're going to do is we're going to not only get this thing that spawned, but let's us actually apply force to this thing, okay? So this thing is Kai, which is our ball, and what we want to do is actually apply a force to him. So if I drag a wire off of this thing, this guy actually returns the ball that was just spawned. And the ball that was just spawned is what we want to apply force to, so we're going to work off this return value. The first thing we need to do, though, is we need to convert it into the ball that has the actual physics mesh. This return value is actually just a generic actor. We don't know if it's a ball or if it's a player. I mean, we're telling it to spawn one of these things, but we actually have to do the work. So pull a wire off the return value here inside your spawner. And we need to grab the mesh off of him. This mesh is the actual, if I go back to my blueprint, this is the actual physics ball. This is the thing we're going to apply force to. All right, so grab that guy, and you should be able to grab a wire off of him and type like get mesh. If you named it mesh, it might be called something different. It's whatever the name of your static mesh is inside your ball. And on this static mesh, we can apply a force, or we can just set the velocity. So what I'm going to do is drag a wire from that mesh here. I'm going to type set physics linear. And we're going to basically apply a physics velocity to the mesh. Okay, so this is the guy that you want. And I'm going to connect that here.
Neither of those are sharp.
This thing? Did you drag a wire off of him?
I dragged the wire off of him, but...
And did you type get mesh?
Key?
Yeah.
I put set root because mine was attached to the root, but I couldn't get the physics.
You should be able to get the mesh even though it's not the root.
Mine says static mesh 1, not
That's
mesh.
fine. It's whatever the name is of the blueprint.
Okay.
So go to your ball blueprint. So yours is called sphere. So what you want to do is drag a wire from your launcher. And Brenda, you had it. Oh no, yeah, you can type that get sphere. Yeah, that's what you want. That's the thing that's actually the physics. Yeah, set physics linear velocity. That's the name of the function.
Yeah, I think I got it now.
Oh yeah, that looks good. Okay. So let's just hard code some numbers in here, just to make it move at all. I'm gonna just put like 5,000 in for Y, and like 2,500 in for Z. And I'm gonna compile and play. Not quite.
No.
Did I do this right? Set physics linear velocity.
We locked it to the x-axis, shouldn't we?
It should be, oh right, this might be relative. Let's try this. Let's try setting it to X too. I'm just going to play. It shouldn't be on X, but it is on X. Yeah. I need to move my player back a little bit because I can't even see the player. I think, you know what it is? My spawner, my launcher, the spawn point on my launcher is too close to the mesh. It's hitting the, yeah, it's hitting, my spawn point is right there. Yeah, so I'm going to raise this guy up, the spawn point. Because if it collides at all, and maybe what we could do is I could actually just disable collision on these things. Maybe I'll do that now. I'm just going to have no collision. If it collides at all when it's spawning, you're going to lose any force that you want to apply. So it should all fly with the same velocity.
So how is it that we...
And I think I had it right before. I don't think this is.
Generate.
If you want to disable collision, Brianna, just go to
go to
yeah, set no collision on your meshes. Yeah, so it is Y and Z. So yeah, as long as you have something that basically lets you launch a ball like that, I'm actually going to move this back a little bit, maybe even lower him into the ground. Let's tweak the numbers here. He's flying a little too high, so. There we go. Okay, and I can hit my my pillar. You guys got it launching? Is it going out towards the bricks?
Mine's like just dropping.
Yeah, you might have the same problem where it's colliding with something. Oh, go to your blueprint for your launcher. Make sure that you have it set up so that it actually applies. Yeah, see how those two aren't actually connected?
Oh, right.
There's no
I forgot
execution
about
wire
that.
connected to those two. Yeah. Now that's a really fast velocity. So
Yeah.
go for it. How about you?
My camera is a bit noisy. I don't know how to.
Why is your camera sideways, and why are all your things falling to the
It's
ground?
just rotating.
Okay.
We're just going the other way.
Just rotate your launcher.
It's facing the right way.
Oh, you want it facing that way? Okay.
Yeah.
Then yeah, you should either rotate the spot point or change the velocity. So show me what happens, Kai. Can you shoot things?
No.
Okay. So you have a lot of things wrong with it. Is that the camera angle you want?
No.
Why is your camera? Wasn't it working before?
No. That's why I told you my camera is a bit strange.
Oh, why is your camera strange? Did you? Where's your? Okay. Where's your blueprint for your character? Why is your camera so far back?
I tried to change it.
No, don't. Yeah, set those to 0. Set those 0. Set those all to 0. Positions. Just click on that little yellow arrow. Okay. So compile. Okay. That's a little better. So now it's at there. So now we have to move your spawn point. So where's your spawn point? Destructible for player. Grab that guy. Move him out of there. I want you to move him out and paste him towards it, just like what I had.
It's too high.
No, I don't. That is good.
So pull him out. Yeah, have it face that
I'll
way,
make it
and then
faster.
pull him out so he's sort of here instead. Yeah. That's better. Can you move left and right? Okay. Cool. Oh, it's backwards? So your inputs are backwards. Go to your blueprint. Your character.
Oh.
Multiply that by.
Yo, it's the spawn is too high.
Just set that to be 1.
There you go. It's too high.
And play. Okay, we're just going to reverse it. You guys rotate it more. So go back to your blueprint for your character. Just do -1 there. Better? Okay. So what about your physics objects? Were they were always falling to the world like that?
I tried to put
What mesh are you? You can't use that pillar. That's why. You have to use a different mesh for that. So go to your blueprint for your wall. No, those are fine. Those are fine.
A little higher.
Go to your blueprint for these things.
Oh, it's the no.
Can you edit that? Yeah, you need to change that. You can't use that mesh. Use a different shape instead. So just click on that. Click on scroll up. Change that from color and look for a shape like that, a cube. Play. Just want to see that they fall. Okay. So you also need to constrain them so that you have to constrain the X. Okay. So I'll have you fix this up later after class. Open up the blueprint for him again. Scroll down. Constrain axis. Just set that to be X.
okay?
I'm so tired. All right. Okay.
So you have nothing in here to launch the. Where's your behavior to actually move the? You don't have that set physics linear velocity. Wait.
Oh, that's
I think
in the.
you did it in the wrong blueprint.
That's in the ball. That's not supposed to be
Yeah,
there.
No,
this is not. You need to take this, these two. I don't know what this is, but you need to move that into your launcher.
Okay. So, but the spawn actor ball. So none of this needs to be.
Oh, just yeah. I don't know. The ball doesn't have any blueprint yet. We're gonna add some in just a bit, but I would say just cut those. Drag a wire. Drag both of those. Control X. No, you don't want them in there. So Control X. Okay.
Yeah, this one
You
is
have to
wrong.
click another thing.
Which one?
Drag a wire thing right here. Instead of Z velocity, you need to add a little long couple. So instead of Z velocity, you need to get that out.
Oh, that's cool.
All right. So we've proven that we can move the ball, which is the first step. Now let's do something a little bit more involved. You know, the main mechanic in Angry Birds, aside from trying to destroy walls, is that you get to choose how hard and the angle at which you launch these things, right? So let us add behavior to control how hard we fire this ball. Right now, when I play and I click, they all launch at the same speed, no matter what. I can't control them. What I like to do is the longer I press the left mouse button, the stronger the shot is, okay? So I want to set up some behavior so that if I press the left mouse button, I begin charging, and then when I let go is when the ball actually gets launched, okay? What is controlling the amount of force that gets launched for our ball right now?
A set number.
This is right here, right? 5,000 and 1,000. What if I took instead a number and I multiplied it by, say, 5 and 1? Then I could take that number and I could scale it up and use that as our new velocity. So right now it's 5,000. If I want to lower the speed, I could set this guy to be like 500 and this guy to be 2,500. I could cut that in half by just putting numbers at 1/2 of what they are. But what I want to do instead is make this thing based on how long I've pressed the left mouse button. Does that make
Is
sense?
that going to translate over to the pad too? Like
Mhm.
what we were talking about?
So I can show you how to do that with the trigger too. So the longer you press, or the harder you press the trigger maybe, or the longer you press the trigger.
We got a break input and drag it from, I mean, the break vector will drag it from. like,
Yes.
break input to
We're going to, yeah, instead of having this thing be hard-coded, we're going to actually feed it in from something. We're going to feed it into something that basically is a scale. All right, so let's do that first. Take your set physics linear velocity on your launcher, and I want you to drag a wire off of here. And I'm going to have you guys make a vector. Now, this thing was like 5,000 and 1,000 for me, right? But instead of having this thing be 5,000 and 1,000 hard-coded, what I want to do instead is actually feed it some value that's a force that I want to apply. So here I have 5,000 and 1,000. What I'm going to do instead is drag a wire off of Y and Z, and I'm going to feed it, actually there's an easy way to do this. I'm just going to make this thing 5 and 1 instead of 5,000 and 1,000. And let's just multiply this by our force, right? So make a vector, 5 and 1. And instead of plugging directly into here, we're going to actually multiply this by a float. And what happens when I multiply this by, say, 1,000? What does this value end up being? If I take this, 5,000 and 1,000, that gets plugged into here, right? What if I make this thing like 500? What ends up being that value? 2,500 and 500, about? So this value right here that's being multiplied against the vector is basically our force. It's how strong we're going to shoot the ball out of the launcher.
How did you get us float B, right?
No, I just took the return value here, Brianna, from this. Do you have the make vector?
Yeah.
Okay, drag a wire off of that, and I just did the asterisk to do a multiplication operation. And I did vector times float. And then I plugged that result into new velocity here. So this number now, the one attached to the multiplication operation, this is going to be our force. So I want you to right-click on that and do promote the variable. I'm going to name this guy force. And just as a test, let's expose this thing, make it editable. Just right-click on the wire, the link here, and do promote the variable. Make it editable. And then what we can do now is this is not really the way we're going to control it, but just for sake of argument, I can go to my launcher and look on my right. Now that I've made this thing editable, I can control the force here. I can scale this guy up and down. So I can make this thing like 680 if I play. Launches that high. Or I can crank this guy up to like that high. And it's too high, it goes over it. But you should have some number that basically controls how hard it shoots out. I could even make this thing like 10,000. Right? I just want to make sure you guys have that. You should have an exposed force, because that's the number we're going to control when we play.
You can cap that too, right?
We're going to cap that, yeah. We're going to cap that to something reasonable.
If I have a negative number,
It'll shoot in reverse direction.
yeah, it's because if I were to go to my launcher, because mine was like
Oh,
a negative.
motherfucker.
Oh yeah, that's fine. You can keep it. You want your force to be positive. Though. Your force is going to be positive.
Okay, it's
It's-
gonna be positive.
Yeah, we're going to clamp it to be positive.
It's dropping them into the floor again.
Dropping what into the floor?
The balls.
What's your force?
I keep cranking it up. Where did I do it?
Are you using that force in your blueprint? Make sure that let's just double check that. Let's just double check that. So see how these y and z are 0? You want y and z to be something non-zero.
Okay.
So make that like 5 and 1. So my goal here was just to make a one number that controls how hard the ball fires out. We're not controlling the aim yet. We're about to do that next too. We want to be able to aim this thing up and down. I'm going to have an arrow that shows you where the ball is firing out of. Okay. Yeah, but I have this. And the force is kind of crazy, and you probably don't want it to be as crazy. But, wow, even 1,000 makes it go over. Right? And we're also going to make sure that we can't shoot an unlimited number of stuff going faster. Does it fire? Does it really fire? Stop firing. Click on your launcher. Okay, go to your blueprint for your launcher. So you want your y and z, this should be 5 and 1 here. That should be 0. Y should be 5. And z should be 1. And go to your components. And click on your mesh. And I want you to disable collision noise. So scroll down and set up block all dynamic to no collision. Same for your face. Compile that and try it. Oh, okay, so it's launching. It's going backwards. So all you have to do is reverse it. So go to the blueprint and graph. Multiply that by negative 5. That's 1 of 2,000. Okay. All right, so that's all well and good. How about we do the aiming mechanic first before we go on to pressing and holding the button. I'm worried that we're going to run out of time. So let's add some components to help us. I don't really know what's going on with the game as far as like why it's all foggy. I think something went wrong. What's that? Quality settings? I don't think there's any such thing. Yeah, I maybe atmosphere? I don't know. I'm not going to worry about it. You can still kind of make out what's going on. False. Go to your launcher, and we're going to add an arrow on the launcher that lets us show what direction we're aiming. So add an arrow component, and make the arrow component a child of the spawn point. Once you've made the arrow component a child of the spawn point, zero out its position. Okay, that's what the arrow looks like that. And I'm also going to scale this guy up quite a bit, maybe like 10.
Change the color.
Sure. Also, when you add your arrow component, make it not hidden in game so that it shows up in game.
If you adjust the scale, that changes the length. But what about the arrow size right there?
You know, this thing is like more like how big the whole thing is. It is a scale, but like we're going to actually use the scale to control. It's going to show the power. It's going to scale up over time. So the longer you hold it. Okay. So when you play it now, I really don't get what's with the, I'm going to save this and reopen the project real quick.
I couldn't see it because it was the same size as my widget for changing the size of it.
Yeah, make sure that you've unchecked the hidden in game too. Jump into your game, make sure you see an arrow. We're going to use this arrow as the actual spawn point. We're going to also use this arrow to control what the orientation of the ball that fires out of it is. Okay. It's still all fuzzy. That's a shame. I want to say it's like the post-process here. Note depth of field, post-process volume. It's just like super blurry. I've seen that before. This will have to do. So we have this arrow. I'm actually going to change the color of this thing to make it a little bit easier to see. And this arrow is bound to the spawn point. It's kind of facing the wrong way, so I'm going to rotate my thing again. So let's set it up so that as we move the mouse up and down, that this arrow moves up and down too. And at the same time, we're also going to rotate this thing. Notice as I click on my spawn point, and if I go and open the rotation widget, the arrow rotates too, right? So as long as we can rotate the spawn point, the arrow will rotate, and by the very fact that we're spawning at the spawn point with its rotation, it'll also shoot the ball in the correct direction too. So go back to your graph.
So the arrow should be a child of the spawn point.
Yes, definitely. All right. So right click in your blueprint. We're going to add a mouse Y event. So just type mouse space Y. We can also do this using the axis mappings that I showed you guys earlier, and I'll show you guys how to set that up later. So if you want to do like touch events or the joystick, you can do that too. All right, so add a mouse Y event. Brianna, you got this? Mouse Y. Okay. And I want you to grab your spawn point from the left here and drag him into the level. We're going to rotate him based on the rotation of the mouse. So once you have your spawn point, pull a wire off of him and type local rotation. We're basically going to add a local amount of rotation based on how much we rotate the mouse. We're going to pitch this guy up and down. So local rotation. Connect that here. And all we want to do is adjust the pitch. We don't really care about the roll or the yaw. We just want to move it up and down. So I'm going to grab a wire backwards from add local rotation. And type make rot. Which lets me specify each of the components. I'm just going to drag that into the pitch. What's that? I can't hear you, Kai. What'd you say? Are you talking to yourself or are you talking to me? You don't know. So if you have this set up now, your arrow, when you move up and down, should go this way. And the balls are still going the old way. We have to change that too. But your arrow should spin around, right? Do you guys all have an arrow spinning?
So then you're just going to count the rotation of that and apply it to the sphere.
Yeah.
It's like a bowling ball.
Okay, so let's actually have it right now. The force that we're applying is based on a 5 and a 1 here. We're going to replace that with the spawn point rotation. So go down to where you're applying the linear velocity to physics, drag the spawn point in the level. We'll do something a little bit different now. We're going to get the world rotation out of the spawn point. What did I do here? The transform, get world rotation, spawn point. We need to actually take this thing and we're going to actually move it so that it spawns inside here. But we also still want to multiply it by the force that we specify here. So right now, this is always going to shoot 5 units forward and 1 unit up. But instead, what we want to do is we just want to have it shoot towards the vector here. So I want you to delete this vector. And this guy used to plug into here, but you know what? Maybe it's because of the unroll. Yeah, this is not it.
Can you promote it to already?
No, this thing is actually... Sorry, give me a second here. Get world rotation. Yeah, this is fine. We're going to do this. drag a wire off here. Instead of doing rotation, we're just going to do get forward vector. And we're going to plug that into the multiplication operation that we have here.
So it just returns the x.
It just returns a forward vector. In 4.5, I think it's a 4.5 thing. It lets me it was letting me take the rotation and plug it directly into here. So we're basically taking that vector and we're multiplying it by the force, and that's the velocity that we're giving to the ball. And now that we're giving that velocity to the ball, the force is a little bit too low, so we're going to crank up that force too. Notice here, if you have it using the forward vector, now it's following the arrows exactly. I'm sorry? If you have it exposed in your launcher, it's that thing. If you expose it, yeah. If you just go into the level, you can click on your launcher. We're going to actually make that in scale based on how long you press it. Cool. Okay, so it's launching
So I
based on
assume that you call an event that is when I start keys down.
Yeah, we're gonna.
You start a
That's
timer, and
yeah.
then you can use that timer as a multiplier.
It's we're gonna hook into the tick, and we're gonna make it go up. Cool. So it's launching in the direction that we're aiming, right? Okay. Almost there. So Brianna, do you have it launching in the direction that you're facing as well? So it looks something like this.
Yeah, it's just very weak.
You can crank up the force, but I wouldn't worry about that yet. We're about to just make it crank up anyway, based on how long you held down the mouse button.
Yeah.
Okay, so right now, when we press the left mouse button, that's when we spawn, right? I want to change it so that when you press the left mouse button, you start charging your force, and then when you release it, that's when you spawn it and use the force that you've accumulated up to that point, okay? So here's the left mouse button. What I want to do is I want to have this force variable increasing as long as you have the left mouse button held. And one of the best ways to do that is to use something called a gate. And a gate is a really simple concept. It's just like if you think about a regular gate, like a real gate in real life, it's just a way for you to prevent or grant access to a part of your blueprint. So your gate can either be open or closed, and if it's closed, then nothing can get through that gate. If it's open, then all of your execution can go through that gate. So it's allowed to continue past it. Before I move that, I'm just going to organize this stuff a little bit. I'm going to put a comment around here, move arrow based on mouse. So go to your left mouse button event. And I just want you to disconnect the link. So just Alt-click the pressed. So you just have this left mouse button that has nothing in it. Okay? And I want you to right-click and add a gate. Now, a gate, as I mentioned, starts off as closed, meaning that nothing will be allowed to fire past it. So if you say, hey, gate, I'd like to continue executing, if it's closed, nothing will actually happen. So what we're going to do is we're going to open the gate when you press the mouse button. The gate, in our case, is going to be in charge of increasing the power of our force. Okay? Do you have a gate, Brianna? Okay. So when I release, I'm going to close the gate. Okay? So we're going to base our increase based on a tick. So this gets called every frame. So I want you to add an event tick and connect it to the gate. And just to prove to you what's actually happening here, I'm going to do a log. You don't have to do this. I'm just showing you I'm logging whenever the gate is open. So notice here, this exit wire will only fire if the gate is open. So if I compile and play, so as I'm clicking, you see those log messages show up? If I click, the log messages only show up while I'm clicking. If I have the left mouse button held down, that's when the messages show up. So that's how I want to set up my behavior. As long as I'm holding down the left mouse button, I want to add these numbers to the force, multiplied by some amount, so that the force goes up at a reasonable rate. Okay. So we've proven that this thing only runs when you're holding down the left mouse button. So what we're going to do is I'm going to take this force here, I'm going to drag it in, and you guys can drag it in and set the force. I basically just want to add a number to it as long as the gate is open. So I'm going to hook up the wire here. I'm going to pull a wire backwards from here. I'm going to type plus. And I want to add this delta time into the force. But that's going to be a little slow. So instead of plugging a wire directly from this delta seconds into here, like that, which will only add it a very tiny bit at a time, I'm actually going to add it much faster than that. So I'm actually going to take this delta seconds here, and then multiply it, and do float times float. What's that?
I was just wondering if it was a floating integer to float.
Yeah. And I'm actually going to multiply this by like 3,000. And then finally, I'm going to drag the force variable onto the plus, which means I'm adding this number here. Let me comment this here. Add 3,000 force per second. 3,000 force per second. And drag the wire into here. Okay. So now the gate will say, hey, whenever I'm pressing the left mouse button, take the delta time, multiply it by 3,000, which gives us 3,000 force per second, and then add it to the force here. And then actually set the force.
Have it print out clean up.
Oh, that's a good idea. Why don't I do that? Just for showing you. So what ends up happening is that as I'm playing it, you see a number start at 0 and count up really fast. Right? Notice that when I clicked again, it didn't reset it, so let's set up that behavior too. So I want to set it up so whenever I've clicked the button, let's reset the force as well. So you guys have this where you have delta time plugged into here. You're adding force every second. Let me organize this a little bit better here. This is going to be spawning. And this whole thing is going to be I actually don't need these.
What's the name of that node?
What's that? Which node?
The one that you're messing with right now.
This is just multiplying. I just took this and I multiplied it by 3,000.
All I get is multiply by pi.
You should have multiply. It should be float times float. If you pull a wire off of delta seconds, you should see float times float.
Fair enough.
And that plugs into here.
What are you getting that error for?
This is just because I haven't compiled. So we're also going to have to reset the force when we press the mouse button. So every time I click it, it starts it off at 0. So on this wire, type set force. And I'm just going to reset it to 0. Here. And what ends up happening is that when I play now, every time I click, it's going to reset the force and eventually add up. Okay. All you have to do is pull a wire off this and do set force.
Why isn't it firing?
It's because we disconnected it from firing. Okay. Then finally, it's not firing because this thing doesn't have an input. And unfortunately, there's no way for me to like hook into this thing twice. I want to close the gate, and then I want to immediately fire the ball. And the best way to do that is to not like wire it up all the way from here around. But instead, what we want to do is if we know that we want to do one thing and then immediately do another, but we don't want to like pull wires everywhere, it's better to use a sequence for that. So if I pull a wire off of released, what we're going to do in a sequence is we're going to close the gate like this, and then we're going to spawn a ball like that. This will let us do both things off of one input essentially, but in that order. So it does this, and then it does this right afterwards. It's as if I took a wire from the end of this almost and plugged it into here. But the key is that I only want to do this when I've released the mouse button. And then what you end up with is something that fires with more force the longer you hold it.
So the sequence needs to go into the white plug for spawn after ball.
The first sequence, and then 0 goes into close. So we're going to close the gate. We're basically stuck. The gate is controlling whether we're adding force or not. And we don't want to keep adding force as long as we're not holding down the mouse button.
I'm just missing, I think, one more node.
On here?
That part, yeah. So that's add. What is the one that allows me to put more into the set force?
That's this guy right here.
Yeah, what's...
So this is all I did. I just pulled a wire off of this guy. I just typed plus. Right? Plug that.
Float plus vector plus float?
Float plus float.
Okay, got him. And then he just goes into the...
He goes into here. But also, Brianna, make sure that you check, you drag the force from here onto this guy here. You're adding 3,000 per second to the existing force. You have to drag this guy, this force, onto here.
So how would you cap that? Because obviously you don't want it to be like forever.
Yeah,
force, like
that's a good point. We should just do that now, too. Does that make sense? You look lost.
you would just check a branch.
Okay.
Right? You do
So I'm going to do this over again.
No, I've got that part. It's the next part it plugs into.
Oh, this part here?
I thought I had that, but it's not.
All you have to do is drag, Brianna, all you have to do is just click on this, hold down Alt while you drag it in, and then there you go. And then plug that wire in to the gate.
I think I lost you because I didn't rearrange my sections like you.
Oh, I see. Yeah, yeah. Yeah, it can be, it's important to like keep your stuff organized because sometimes things get everywhere.
I just had.
Johnny, you good? Do you have this thing? What about you, Kai? Okay. Does it increase in force as you fire?
really powerful.
Okay, because like this rate here controls how fast it goes up. We need to clamp it though because Angry Birds doesn't have like an unlimited amount of force. It kind of is more like a, hey, there is a maximum upper limit of how strong it can be.
I don't need the spawn point, get forward vector, and force, right? Anymore? No, but it's.
No, you do need that, yeah.
That's just the second section. Okay.
Yeah.
It's just kind of hard to see how much force you're adding to the arrow.
We're going to scale the arrow based on how much force you have too.
Shit.
Show me the blueprint. Go here. Drag up the force, okay. this whole section. Just drag out, yeah, grab all these things. You can box select. Yes, that's better. Hit C. Yeah, drag a box around all those things and hit C. Type spawn. Just click on it once. Click on the comment thing once. Do that thing. Yes. Cool. And you probably do the same thing for this. Yeah.
But now I have an error.
Just compile. It'll go away. Try playing it now.
Well, comparing it to my last graphics card, it looks nice. Yeah, it has LED lights on it. I have a window.
Show me the blueprint again.
I have a window. My case has a window. Yeah, but it has a window, so lights come through.
So you don't have anything to enter. Where's your? You need an event tick. Oh, you do have an event tick right there. But here. And then set force is on release. Oh, you need to not do this. This set force needs to be on press instead. So zoom in.
Press.
Yeah, zoom in. Connect the press to that one instead. And then this one goes into close. And this one goes to open. Set goes to open. Now that'll work. Okay, look at that.
Oh, shoot.
Okay.
Awesome.
All right, so let's clamp this stuff too, because we have this force and it's effectively unlimited. Like the longer you hold it, the more it'll fire. But it's really easy to limit the amount of force. So right before you're about to set it, we're just going to do one final thing. Pull a wire off this and type clamp off the add and type clamp in there. And clamp just says, hey, it has to, if it falls below or above the min or the max, we're going to make it the min or the max. It basically has to fall within the range here. So the min can be 0, and the max I'm going to set to be like 5,000. This will make it so it can never go above 5,000 force, no matter how long I hold the mouse button. Okay, pretty simple. So then if I hold down the mouse button for like any seconds, it still only launches that far. Okay. All right. Cool. Should we make the arrow scale based on how much strength there is too? I think we can do that. Actually, shoot. We have like about half an hour, so let's do the enemy. Let's do the destruction behavior and the enemy, because that's pretty simple, and then we'll come back and we'll do some polish work on this, okay? So let's make these walls here destructible. We have this thing that's launching, and it's great that they're knocking down the wall. But what we actually want to do is we wanted to destroy the walls. So open up the blueprint for your wall. Okay. And just right click and type hit. And we're going to add the event hit onto here. And this will get fired whenever anything hits us. It actually also gets fired whenever we run into the environment. So we're going to do a little bit of work to make sure that we don't destroy our walls as soon as they spawn. But this is actually very, very simple. All we need to do is this event will fire whenever something hits us. So let me just show you what actually, what interesting information comes out of it. So I'm just going to plug in a log here, and I'm going to plug in the impulse into the string. And this is just going to print out whenever the walls hit something and there's force applied. What you'll see is that there's a bunch of force applied right at the very beginning because the walls drop to the ground, right? But also, when I shoot them with the ball, they also show impulse. So your walls understand. Oh man, this doesn't have the. Interesting. it's called something different in here. But you can see here how the values, if I just tap it, it still kind of goes crazy. What we want to do is we want to filter out like the small collisions versus like the ones that are actually big, so we can give credit and destroy the walls only when a certain amount has been hit. So why don't we do this? Let us drag the wire off of the normal impulse, and we're going to get the length of that vector, which is just the total components of the vector, the distance of that whole vector. And we can use this number to compare how strong the impact was. Okay? So I'm going to take that vector length return value, and I'm going to just compare it to see if it's greater than another float. And the number that I had here was 150,000. And if it's greater than that, I want to destroy this wall. So I'm going to pull a wire off this red output. I'm going to type branch. And in the true case, all you need to do is call destroy actor. So before you guys freak out, like when the level starts, your walls may destroy themselves because of how high up they might be in your level. We'll be able to fix that in just a second, too. So now this is basically saying, hey, if something hits me and the total force is greater than 150,000, destroy myself. Okay? So I don't know if it's actually going to destroy the walls. Notice how some of my walls got destroyed here. So if I launch some of these balls, and I think if they just tap it, they won't destroy it. Oh, they will. Yeah, 150,000 might be a little bit too small here. This is totally a fudge thing. This is totally just like, hey, try to play with values until you see something that works for you. You want it to be high enough so that the balls require some force to destroy, but not so high that it's not possible to destroy them at all. Okay? So maybe 250,000. And then what we want to do is we're going to want to give, like, let's say I have a map with a wall that's kind of higher up in the air. Like, let's just say I raise that guy up. Like, if I raise that guy up in level, it just destroys itself. What we want to do is give it some kind of warm-up time so that within the first couple of seconds of the map, that walls aren't allowed to destroy themselves. Okay? Brianna, do you have this set up?
Almost in one node off. It's just, is that a float or
This?
that one? Yeah.
It's just comparing this greater than. You good?
Yep.
Okay.
That was the only thing I did.
All right, so let's give it some warm-up time. Hook up a event begin play. And we're just going to hook up a delay to that for maybe 2 seconds. So it's an event begin play that hooks into a delay. And what we're going to do is use a gate again. We're going to open up the gate that allows it to destroy itself after 2 seconds of fire. So off of this, hook up a gate. But instead, it's just going to open the gate when the delay is finished. So it starts off connected to this, but instead reconnect it to the open, like that. So we're going to open the gate after 2 seconds. And now the event hit is, instead of going directly into the branch here, we're going to go here. Enter. And then the gate's going to plug into the branch like that. Oops. What? So your blueprint will look something like this, where you have event begin play hooked up to delay that opens the gate. Whenever you hit something, it's going to try to pass the gate. Which will give it the ability to kind of fall over itself for the first couple of seconds of the map, so the wall won't destroy itself. So notice at this time the wall fell and it didn't do anything, but I can still aim my, oh shit, yeah. It still destroys. Kind of like Angry Bird style. I mean, you kind of have to figure out for your tuning what that value of force is going to be. I don't know, it's kind of Angry Birds-ish. Like maybe I could bump it up a little bit more.
I think I've done something more of it wrong, so.
I'll come by just a second. We're almost done, actually. So we have destructible walls. All we need are enemies, and then.
So, because sometimes it was okay. So it was destroying itself when I played the level, but it's not anymore.
Okay. Do you have the delay and stuff set up for your wall?
Yeah.
Show me the blueprint. I just want to make sure it's set up correctly. Perfect. Okay.
So when I hit everything.
They all kind of blow up, right?
Yeah.
Yeah. So you have to tune it to your meshes. It's probably too easy. So you just have to crank up that number, that really big number, up to something maybe even bigger.
Bigger.
Yeah, play around with it. It's not an exact science. It's kind of, this is what prototyping is for. It's you have to kind of play with it until it feels good for your game. Okay. So let's make enemies, and then let's make the heads-up display. So the best way to make an enemy, now that we have a wall that works correctly, is we're just going to duplicate this wall. So grab this thing, and we're just going to create a copy of the wall blueprint. And I'm going to name this guy the enemy. And instead of it being a gold-colored cube, you guys can replace the mesh with whatever you want. I'll make this guy. Okay, I can live with that. I just clicked on my wall and I just did create duplicate, create copy. Yeah, it's like right in the middle. Right above rename. I'm just going to put one of these guys in the level. Yeah, that poor little guy. That's Angry Birds-ish. I feel like that's, you know, he fell and then he died because of the fall. I think that works. So yeah, just
Angry Birds, like some of them can actually take more than one hit though, right?
yeah, you can make them stronger as well. So you can actually have multiple lives, like you said.
And then every time it hits a collision, just tack one off.
Yep.
If it hits 0.
Exactly. You can even change the state of this thing so it looks different. Does everyone have an enemy that's a duplicate of a wall? Make it look a little different too, it'll help. I don't know if this thing is.
I like say, there's so much fun with this.
Yeah.
Do you teach any classes after this, Keith? I
Hmm.
mean, after game prototyping?
No.
Is this your last year or something? 'Cause
No.
Ben's taken over.
I don't know, that's a good question for Kim.
So
Oh,
are you
where?
here next quarter?
I'm here. Unless they get rid of me for some reason. Yeah. I wanted to.
Because then we have like Mr. Chose and
Yeah, I learned so much more in our first prototype class with programming and Unity than I did with any other class.
I know. I offered to teach those classes too. I don't know. If you guys want something done, you should probably go talk to Kim or Ben.
yeah, because then Ben is like, how can you teach nothing to me?
I want to teach those classes. They don't give those classes to me, so I don't know. You guys should talk to Kim.
We shall complain.
Okay, yeah, complain. Right, so you guys have enemies in your level? We're almost done. It's not going to take more than 5-10 minutes to finish up the rest of this.
Yeah.
Then I'll give you guys homework. Enemies? Brianna, you got an enemy?
I do have an enemy.
Okay, cool. It should be exactly the same, except there's going to be one slight little difference. One little difference. So these enemies we're going to keep track of them. We're going to keep track of how many of them are left. But let's put up a heads-up display in our game first. Let's show how much score we have and how many, I guess not score, I guess just how many enemies are left to kill. Let's just do that to start. And we're going to do something that we haven't done yet before. And this is actually going to be really kind of pretty common from now on. You're going to have cases, like you actually had this case, where you're going to want to store information across all of your blueprints. You want information like score and lives and enemy remaining and what power-ups you have, information that you want to share across each of your blueprints, and you're going to want to store that somewhere. And so the place you're going to store that is what we're going to be using is a game state. So game state is a way to share information across multiple blueprints without having to do any kind of like janky behavior. You can always get access to a game state no matter what blueprint you're in, which is why they're really convenient. You could be in your ball blueprint or your wall blueprint or your launcher blueprint, and they can all get access to your game state. So make a new class blueprint. I want you to search for game state under custom classes down here this time. Okay. It's not one of these. It's game state. Okay. So select that guy. It's under custom classes. What's that, Kai? I just named it BP underscore game state.
And this is still considered a class blueprint, right?
It is a class blueprint. Yeah, so if you go under class blueprint, custom classes, type game state here. You got it, Brianna?
Yep.
Okay, so go open up your game mode blueprint. It should be like my game, or mine is rolling game mode. And in this drop-down box, I want you to select your game state you made. This is pretty pivotal as far as like this is where you're going to store all your variables that you want to share amongst the various behaviors, the various scripts that you have. Okay, you have it selected there. Cool. So go to your game state. The first thing we're going to do is I want to collect all the enemies that I have in my level. So I'm actually going to put like 2 enemies in my level here. That. So I have 2 enemies in my level, and instead of like doing any manual work to count the number of enemies, let's just let the game count the enemies for us, okay? So open up your game state blueprint and add a event begin play. We're going to collect all the enemies that are in the level and store them in a variable. Okay.
An array, correct?
Yep. We actually don't even need to store them in an array. We're actually just, all we need to care about is how many are left alive. Okay, event begin play. So what you're going to do is drag a wire and do get actors, plural actors, and you're going to select get all actors of class. And in this class, you're going to search for your enemy type here. So in the drop-down box, select the enemy blueprint that you made. Okay. Make a new variable, call it enemy count, and it's going to be an integer. This is going to be kind of weird, but we're not actually going to care about the array. We just want to store how many people are, how many enemies are left. So I want you to pull a wire off this, or this actors array, and type length. Length will give us how many enemies we have. This actually is exactly how many enemies we have. And then we're going to drag a wire from here and do set enemy count. And then connect it here. That's it.
Okay, so I have a question.
Yeah.
So that variable that you made enemy count, since it's in this kind of blueprint, I should be able to access it in
The level, the HUD, the player. Yeah, we're going to access this everywhere, actually. Okay. So let's make a HUD. Let me just prove that it's actually doing this too. I'm just going to log a string, and I'm going to print this. So see in the upper left it says 2 up there? Did you guys see that? Blue number 2 right below lighting. That actually changes based on how many enemies I put in my level. 5, right? Okay. So as I add each enemy, I get that number increase. Okay, so this is why you're going to be able to make new levels really quickly. All you have to do is add more enemies, and it takes care of itself.
So much easier.
All right, let's make a HUD now. This is going to be our simplest HUD ever. All right, so make a new class blueprint. Search for HUD in custom classes. Okay. I'm going to name it BP underscore HUD. Okay. And then go to your game mode and assign your HUD that you made here, just like you did for the game state. Pretty easy. Okay. Go to your blueprint for your HUD.
Do you go back to the top?
This one? It's just the HUD class. Okay. So go to the blueprint for this guy, for your HUD. We're just going to draw text on screen that shows how many enemies are left. Okay. So if you right-click and do event draw, add that event, and pull a wire and do draw text. The first draw text that you see, not the second one. Okay. Set the color to be something non-black. I just use white. That's fine. If you don't have a font, you'll have to make one. Like I don't have a font yet. So let's go make a font. Making a font is super easy. Just go to your level, and under New, Materials and Textures, select Font. Make it rather large. Eraser. I'll just call it whatever you want to. Just make a font. And then select that font here. As a test, just type in some text here, some gibberish. And when you play, it should show up in the top left corner of your screen. Okay. You good, Johnny?
I actually
Kai?
didn't change the size before I added it. Is there a way to
You
add
can scale it here. It's not perfect. It's going to look pixelated, but better than nothing. You could always just make another font.
You just build a string with an integer from that point, right? And then just
Mhm.
put it into the text field.
Yep, that's what we're going to do. So pull a wire off a text. We're going to convert it to a string. Pull a wire backwards from there and type format text. And here, we're going to type enemies remaining. And remember how you format this. Curly braces, and then the name of what you want to plug in.
Can you pull out another string real fast? I just want to see if something pops up.
Wait, pull out another string. You mean here?
Yeah, and type in build string int. Yeah, I think that does the same thing, right? Because you can append it to the front and then just plug in an integer.
Yeah, this is kind of very more strict. It expects an integer. I like this because it's kind of generic. It'll format whatever you plug in here. Okay, you guys have a format text? So here's the tricky part. We have game state, right? We have game state. That's where the enemy count is. We logged it out to the screen. We can get the game state from here. Right-click and type get game state. We're going to need to take this. This you can call from any blueprint. But it doesn't return your game state that you made, so you have to cast it. So pull a wire and type cast. You should only see one option there. Okay. And then pull a wire off the bottom link, the as BP game state, and type get enemy count. And you can plug this into here. And then we're missing one more thing. This thing needs an execution wire connected to it. So we're going to actually have to plug in this guy here, the event receive HUD, and this guy plugs in all the way over here.
I have a question.
Yeah.
So with these class blueprints now calling from the game state, and I know how you say you could take any class blueprint and drop it into any game and use it. So is it going to hit an error now that it's requesting a custom game state?
Oh, if you took another blueprint, you can't just take a blueprint for an enemy. When you export it, it's going to say what references it has, so it'll ask you to export those as well. So it'll pull the game state with you. The what? Kai, what did you just say?
How do you do the path to game state?
I pulled do you have get game state?
No.
So type that first. Right. Add one of these. Okay.
Get game state?
Yes. Pull a wire from here and type cast.
No.
And then that's what you get. And then what you'll end up with is, in the level, enemies remaining will be that. And as you destroy them, nothing happens because we haven't updated it yet. We still have more.
I have the.
You have to type the format. So type like what you want to say on the HUD. And then curly braces. Has the name of the variable. Like whatever.
Yeah.
Just type. It can be literally anything. Just type yeah. And then drag that into the enemies. And then I need you to connect. Scroll up a little bit. Connect this to that. This goes into there instead. But yeah, and then this goes into here. Okay, now try that. No. Go back to the HUD. It's compile error. It's because your format text, when you type it in, there's something weird. Delete that format text. Delete the whole thing. No, delete the whole thing. Do that.
Oh.
Compile. Still an error. Something got messed up. We need to try this. Try deleting that event received HUD and compile. Okay. Do that over again. So add an event received draw HUD. Put them into there. And then you'll need a format string. So pull a wire off of there. Format. Yeah. Zoom in. It's really hard to see. Yeah, add in. Yeah, plug that into 0 instead. Disconnect the one that's going to format. And type your text in and everything. The format again. You guys have stuff running in the HUD for how many enemies you have? You should see like
My HUD is like this. After I broke the connection for this, and then it's not showing. Now it's showing that instead.
it's probably your format's text that's broken. So go to your blueprint. Yeah. Format looks good.
And then what do you plug the result into?
Result
I was
import.
looking for it, but there's
The format text bubble. Do we plug result in anywhere? Oh fuck! Got another error again.
Okay, so your format text to result should go right into
Text there.
text.
You don't have text in the draw text in that.
Then.
How would you try?
Nope.
When you get an
Fucking error.
Just put some random text in there. Try. That works. So show me where's that? Show me the HUD.
How do you plug into that on my screen?
Do you have a font something? Is it? Does it draw anything? Is this? Oh, did you assign this to your HUD? Go to your game.
No.
Go back to your HUD.
getting some kind of crazy compiler error over here.
When I recreated the format text node, it did the same error as last
I
time.
figured it out.
What was it?
When we put like went to my game, like before it was working like for the game state.
Yeah.
Like I've had BP underscore game state, but when I checked again, it disappeared.
Oh.
So I think when we broke the connection, like to plug it in for events.
So it does
and
make
all,
this
Oh,
error
I
every time
see.
you make
So
this
it
You
might
might
have
have cleared it.
But it won't go. It makes it. It starts making the error when I create that node, but the error won't go away till I delete both of them.
Let's just do this. We'll just do this right first. Let's just see if we get. Oh man, your Coke keyboard. Because your blueprint got back up.
You didn't compile it.
That was an issue.
Okay.
Yeah, the only reason why this usually happens is was it ever working?
No. Well,
Did it ever compile?
I got text on there.
Oh, okay.
It was whenever we were writing gibberish.
Oh, you're using a later version of it as well. Okay. So no gibberish there. Don't see anything yet.
I used Adobe Gothic.
It's weird. They should be drawing something exposed. There's the gibberish. Let's just try something else here. So that's working. Cool.
So why does this normally happen?
Because I'm gonna plug you shit. Nothing different about what you did versus that. And now you're doing stuff right there. Let's just leave it as that for now.
Okay.
Okay, that's fine. I don't really want to spend a ton of time on HUD because we're already out of time. Let's finally do the last bit where as we destroy enemies that reduces that number. Okay? Because as it stands now, I have 2 enemies remaining. And as each enemy gets blown up, I want that number in the top left to go down. Okay? So go to your game state. Go to your game state graph, and we're going to add a custom event that says enemy died. Okay? And I just want you to set it up so that we subtract 1 from the enemy count when an enemy dies. Okay? That's up to you guys to set up correctly, really quickly. Okay. So it's just enemy died is a custom event that subtracts 1 from the enemy count. Okay? So all we have to do is call this custom event whenever an enemy is killed. So go to your enemy. At the very end, right after it destroys itself, we're going to hook up the same thing we did in the HUD. So get game state, cast it into your custom game state, and then we're going to call enemy died, like that. That's what it looks like in the enemy blueprint. So you basically get the game state first, cast it just like you did in the HUD, and then call enemy died on this guy here. So now as these enemies get killed, it goes down to 0. Okay.
We have Angry Bird.
Almost.
How do you make Angry Bird?
What's up, Brianna?
It's not showing enemy died as an
You have to pull it off the wire of the cast. So go to your let me get this out of the way, sorry. Go to your enemy blueprint, right? Pull a wire off this, the blue one, and type enemy died there. And make sure, oh, you have to also make sure that you compiled your blueprint for your game state before. It won't show up unless you've compiled it.
It's still not showing up, and I've turned off context sensitive.
Okay, let me just test.
So I compiled.
Yeah, pull a wire off that. Show me your game state. That's not the game state. That's why. It's because your custom event's not in your game state. I think you're probably putting your game number. Or your enemy. I don't know where you put it. Where did you put that custom event?
Is this supposed to be?
No, go to game mode. Like that. Okay, go to your HUD. You didn't add a custom event, that's why it's not showing. So go to game state. Add a custom event here and then it'll show up.
For the
How you guys doing?
enemy count, subtract, what else is like?
Well, you have to subtract. You're subtracting 0 right now.
Oh.
And then what is the custom event plugged into?
You're going to subtract 1 from the enemy count. Sorry, I'll be over in just a second. I just want to make sure that's kind of simple for you. Show me what's not working.
Okay. The enemy is not dying, and
Are the walls dying?
the enemy is not dying.
Are the walls dying?
Yes.
Did you duplicate your enemy off the wall?
I duplicate the script.
You have to duplicate the enemy. So show me the script of the enemy. It's much easier to like just duplicate the enemy off the wall. Yeah, because the reason is because stuff like this, right? Because you probably forgot to check the generate hit events. What are your components not on your mesh? Slow down. See that checkbox. This is why you duplicate stuff from things that already work. It'll save you time. That's so useful.
So what's the whole